Welcome to clickmyproject.com.
Yeah, let us discuss about the novel initialization scheme for fuzzy Siemens algorithm on color image segmentation. Yeah, let us discuss about the abstract of the product. So, the objective of color clustering is to divide a color set into C homogeneous color clusters. Color clustering is used in a variety of applications such as color image segmentation and recognition. So, fuzzy clustering models have proved a particularly promising solution to the color clustering problem. So, such unsupervised models can be used with any number of features and clusters. In addition, they distribute membership values across the cluster-based natural groupings in the feature space. So, in this proposed work, a novel initialization scheme for fuzzy Siemens clustering, that is a FCM algorithm, is proposed for the color clustering problem. So, given a set of color points, the proposed initialization scheme extracts the most and distinguishable color referred to here, the dominant colors. The color points closest to these dominant colors are selected as the initial centroids of the FCM calculations. To obtain the dominant colors and their closest color points, we introduce reference colors and define a fuzzy membership model between a color point and reference color. So the effectiveness and reliability of the proposed methods of the particular various color clustering of the examples. So the segmentation of the images were helpful in the identification of the different regions in the images. So clustering of images separates the images based on the color difference, intensity difference, and etc. So the proposed kernel FCM, that is a fuzzy Siemens clustering algorithm, is intensity based method for clustering of images. So in FCM clustering, the images regions were clustered based on the fuzzy logics applied to the images, and this proposed method of kernel function were employed to the differentiate of the portions. So the efficiency of the clustering process is measured using the performance metrics of the process. Yeah, let us discuss about the flow diagram of the process. So these are the overall flow diagram. In this flow diagram, this is here we are using the data set. The data set set of images are presented, whatever it may be images, it should be getting the input image, and then there are 6 models in the process, and then pre-processing step. So here we in the pre-processing step, here we using the hierarchical approach, and then number of clusters FCM. So there is a fuzzy Siemens clustering, and then clustering process, here we using the FCM process, and then merging clustering results, and finally estimation of the MRC. So these are the overall flow diagram of the process. First of all, the deviation and connectivity are used two objectives to be simultaneously optimized, and the number of clusters can be automatically solved. So however, the chromosome length in this work is equal to the number of data points to be clustered. So the number of clusters is priori specified. So in the contrast, the method uses a variable string lengthy coded strategy to encode the cluster centers, by which the number of clusters can be automatically evolved. Moreover, this method utilizes the global fuzzy compactness and using the fuzzy separation as an objective function, and adapts a validity index to obtain a single solution from the final non-dominant solution of the set. So the FCM is a important method to fuzzy Siemens clustering to cluster the particular images, like the one image is clustered between the two images of the process, and then cluster it should be merged. So merging the clustering result, whatever it may be, and then merge the clustering result for the color combination of the process. Finally, estimate the MRC. So MRC is a minimum mean square error, and then the minimum mean square error should be calculated by using the merging clustering of the results of the process. Yeah, and the number of clustering FCM is used in the block diagram of the process. So I will click that. This is the number of cluster estimation. So number of cluster estimation, we calculating the number of clusters can be automatically evolved. So whatever the cluster, it should be automatically evolved, and then maximum upper band of the number clusters. So the upper band of clusters, it should be calculated, and then gray features derived from the images. Whatever the gray values, it should be feature extract from the image of the process. So this is the number of cluster estimation of the process. And then kernel FCM clustering. So in the kernel FCM clustering is a process speed up the image segmentation process to segment the images by using the speed up process, and then FCM with spatial information. So whatever it may be, the FCM is a fuzzy Siemens clustering process with the spatial information of the process, and then replace the euclidean distance, so to calculate the distance between the euclidation of the process. Finally, restoring the process by using the value of the clustering. So finally calculating the MSC estimation of the process. So these are the overall flow diagram of the particular process. Yeah, let us discuss about the running procedure for the product. So click the main file and then run. So it has some time to run the value. So we will be selecting the images for the data set. So by using the images, whatever it may be, it should be clustered and then process of it should be finished. So this is the dataset process. So here I will select that whatever it may be, the result will be calculated. So I will select that the horse. So I will select open. So the images it will be displayed. So and then we calculating the values for the FCM process and then whatever it may be. So I will select now the first of all I select the input image. So this is the input image. So in the input image I will select the horse. So I will select the horse of the process and the data set of the process. So I will select the horse and then resize. So here we are using the resize 256 cross 256. So resize the image like 256 cross 256 of the process. So this is input and then this is the resize image of the process. And then I will select the adding the noise. The first choice is a salt and pepper and second one is a Gaussian noise. So I will select the noise type is 1. So that is a salt and pepper noise. So the salt and pepper noise will be added in the image. So it takes times to display. So this is the noisy image, salt and pepper noise. It should be added in the horse of the region. So again the next image is a clustering image. So the cluster image here we using the FCM clustering. So the first C means clustering. The clustering process will be applied for the particular horse and then the background of this process. So all the process will be displayed the cluster image in the process. So in the next figure I will select the next figure. So the next figure, this is the fourth figure. So there are 4 types of clustering: cluster 1, cluster 2, cluster 3, cluster 4. So he will using the background subtraction like that. So the horse will be denoted and then the particular image it will be black and white. So all the color invariant it will be binary and binary. So that's the binary scale of image, black and white subtraction of the process. So these are the 4 type of cluster in the process. Finally we getting the performance measure. So performance measure can be calculated: K score, CR score and ARI score. So these are the 3 type of score in the process.
Thank you for listening this video.